Okay, this is a continuation of Math 383, Lecture 18. This is fixing the odd-dependence. So what I want to do, fixing the odd-dependence, is just explain what we did or what I did wrong. So here is omega. And then what we're going to do is we choose some compact k that is at least a certain distance from omega. And so what we're going to do is we're going to say that this distance between the two is very large. How large? Well, let's choose it so that it is at least 3r away. And so if I take any point in k, it is at least 3r units away from the boundary of omega. So here, again, on the outside, this is the boundary of omega. Well, what I can do is I can take another compact set that is going to be at least r units away. And so this is at least, r units from the boundary of omega. And so now, if I take your point z in k and another w in k, I want z minus w to be less than delta. So z and w are supposed to be close. And I want them to be, I want to choose delta so that whenever they're so close, we're going to have f of z minus f of w less than epsilon. So again, these points z and w can be anywhere inside of k. So of course, to some extent, the worst thing that's going to be for us is if we're like right at, if we're right at the boundary over here. I don't know why it's not letting me do that. So, okay. So if we're right. So, okay. So if we have our point z right over here and we have a w over here that's close to it, because we are at least 3r from the boundary of omega, if we are close, we are also still going to be within the blue set, which is all the points that are at least r away from omega. So if I draw a circle of radius r about z, I'm still going to be well separated. Oops. I'm still going to be well separated. And so now what we were trying to do is we were trying to get some bounds. And so we looked at the integral formula. And when we did the integral formula, we got f of z minus f of w in absolute value was less than or equal to 1 over 2 pi. Then we had the perimeter of the disk. And so let's take the disk to be of radius r. So it would be 2 pi r, and I did 2r before, but we're going to do radius r. And then we'll have the bound of f. And for the bound of f, because we start off with the set k, let's let k tilde be this bigger compact set that's at most, that's the points that are at least r from the boundary of omega. So I can then put in a bound depending on k tilde. And now, when I look at what's going on in the denominator, I have the 1 over zeta minus z minus 1 over zeta minus w. That gave us the z minus w divided by r squared. But remember now, r is fixed. We chose r initially. So we chose r, which is really a function of k, or if you want, it's a function of k and omega. So the whole point now is, if we want this to be less than epsilon, we just need z minus w, which is less than delta. We want that to be less than epsilon. And now if we concentrate, the 2 pi's cancel, one of the r's cancel, and we'll get an r divided by b. I can't really write down that far down below, so I will write it like this, times b k tilde +1 inverse. And the reason we put that +1 is just in the off case that the bound is 0, things don't blow up, although we can always say the bound is at least 1. And so this fixes it and allows us to show that we are able to do it with an R that depends only on K and is not depending on how close points are.